All right, good morning. So here's what we're doing for this week. We're going to review and then we're going to take the Hawks test. I gave you the options for the Hawks test, so make sure you're letting me know what you're going to choose on that. But with all that being said, the big thing is you have to have the Hawks done, and I would complete this review for the first part and for the second part, and there'll be a separate one for the second part. So how this works is for each question, they give me about 3 or 4 possible questions they will ask. I'm going to work through all those possibilities. And you guys are going to study this and be prepared to take the test depending on the possibilities. Okay, so this first one, it says simplify the expression. Well, notice they have the same base, so I'm going to add the exponents. Well, 6/3 is 2, so my answer is really just x squared plus 7 squared. All right. B down here, it's a negative exponent, so to make it positive, I gotta put it under 1. And then the next thing you're going to do is you're going to rewrite it with that fraction exponent. Remember, the bottom goes on the outside, the top goes, or outside of the root, top goes as the exponent. Right, well, I've done this a bunch of times, so I know this ends up being 3, and I'm going to cube it, so that'd be 1/27. So the fifth root of 243 is 3, and then I cubed it to get 27, right? And here we're just looking for pairs. Broke it down, be 381, 327, 3 and 9, and then 3 and 3, which gives me that 5 that I'm after. Okay. Next one, last one for possible questions for number 1. If they give you this, right, you just work inside out. So 108, you're going to divide it by 6, right? Because you're seeing how many how many groups of 6 you can make. So you get 18, and then I'm going to take the cube root of that, and I'm going to divide 18 by 3, and you're going to get 6. So your answer is x to the 6. Okay. Number 2, it says factor, add, subtract, or multiply the polynomial. Well, don't forget that there's 4 terms and they say to factor. I'm probably going to group. All right, it's not always going to be the first 2 terms. In this one, I can't group the first 2 terms. I have to do the first and the third, and the second and the third. So if I group the first and the third, I can factor out a C, and I get 5a plus b. If I do the second and the fourth, I can factor out negative 2d, and I get b plus 5a, right? So your answer would be c minus 2d in one parenthesis, and then 5a plus b in the other. Right, so it says factor, add, subtract, or multiply. This next one, you look in between, that means I'm going to multiply. So I'm going to take this times that, this times that. So I'm going to take everything in the first one and multiply by everything in the second. We get 10. You add the exponents. All right. We'll take the 7x times everything. Lastly, we'll take the 8 times everything. And you just go through and see if you can combine anything. And it looks like I can combine these two right here. So when you do that, if you rewrite it, all right, I'm going to get minus 19x squared y plus 40xy. That would be your final answer. So in order to combine them, they have to have the exact same exponents for every single letter. All right. So your answer is that when you multiply. Next one I'm going to add, so I'm just combining like terms. So 3xy minus 3xy, because there's a plus in the middle. So it's going to cancel. Negative 5x plus 4x is negative x. This has nothing to combine with, so alright, plus 2x squared y minus xy squared. That would be your answer. Lastly, they're going to give you this, and they're going to say factor. Well, this one's going to be the GCF. So my GCF on this one is going to be 2x squared y. So I'm going to write that on the outside. Now, to multiply, I would have x to the third y plus 3x y squared minus 5, all left over. That would be your answer. Okay, so that's factor, add, subtract, and multiply. Identify the property. These do show up, so you need to know the properties. Try to pick the four most common property, or three most common properties that you're going to see. This one, right? Notice they kept everything the same. They just changed what the parentheses is around. So in the first part, it was around the negative 3x plus 9. The second part's around the 9 minus 7y. That's just going to be the associative property. Okay. If I was multiplying, I would say multiplication. But because I'm adding and subtracting, I'm going to say because of addition. So it's associative property of addition. Next one. I'm multiplying by the same thing, it's just in a different order. That's called the commutative property. So anytime you have the same thing, okay, and they just switch up the order, that's going to be commutative property. This one's a multiplication because you're multiplying. So the first one is associative property because I changed the parentheses around. The second one is commutative because I changed the order. And the last one that you're going to see that's pretty common, if I multiply and I put it under 1, that's called the multiplicative inverse property. All right, and the other big thing you might see would be coefficients. So it's just the numbers that are in front of the term. So this one's going to be negative 3 and 8/5. And then lastly, there's 5 possibilities for number 3. You might see simplify the union or intersection. Well, don't forget, this is an intersection, so I care about the overlap. So I always like to graph it. A lot of people don't. 3, 2, 21. Just as a reminder, if it's an intersection, I only care about the overlap. It has to be a closed circle on 3 for both of them for it to count, and it does. So this one's going to have an intersection of 3. That's it. All right, if it would have said union, I would say far left to far right. Okay. So that's all the possibilities for number 3. Number 4, the possibilities would be A. So it says evaluate or simplify. We're talking about imaginary numbers. So this right here is going to become 12i, but there's a negative on the outside, so it's negative 12i. I to the 41st. Remember, you always take the number and you divide it by 4. Okay, so you got 10 remainder 1, so you take I to the 4th to the 10th, and then times whatever your remainder is, so it'd be I to the 1st. The reason why I do I to the 4th is because that becomes 1, and 1 to any power is just 1, so the answer is 1 times I, which is I. If you're adding or subtracting, you can only combine imaginary numbers with imaginary numbers, so negative 3i minus negative 12i is going to be negative 3i plus 12i, so that would be a 9i. And 14 minus 22 would be negative 8. And you could write negative 8 plus 9i, it's the same thing. Just depends on the order. And then lastly, you're going to see something like this. If I break it down, 2 and 5. Okay, so this becomes, the first one becomes 2i, because I got the negative on the inside, square root of 5. The second part becomes just I square root of 5, because you can't make any pairs. So this becomes 2i squared times 5 when you multiply. Well, don't forget, I squared is negative 1. So this is negative 2 times 5, which is negative 10. Okay, number 5 is classifying numbers. So here's your possibilities. Remember, if it's over 0, that's going to be undefined. If it's 0 dividing by something, that equals 0. So that's going to be a real number, a rational number, an integer, and a whole number. It's just not a natural number because we don't start counting at 0. And the last one's going to be 1/8. Anytime you have a fraction, it's always real and rational, and you stop there. Okay? Don't forget, irrational is a decimal that goes on forever. Most of the time, it's going to be a square root. That's not a perfect square. Or it could be pi, anything with pi in it. And natural numbers are going to be 1, 2, 3, 4, 5, 6. Obviously, with the example, we didn't have any, but I just wanted to explain those for you guys. Number 6 is to select the symbols that apply or write in interval notation. So this first one, right, they're the same number, so I've got to pick both equal to's, and that would be my answer. Okay? Just as a reminder, if I had something like this, -2 and 1, you would say greater than or equal to and greater than. All right? Bottom one, number 6, you want to write an interval notation. So you're going to say parentheses, -15 to 1 bracket. Because the x is in the middle, it's pretty easy to write. Number 7 gets into your rules of exponents. All right, so I would rewrite this first one with all positive exponents. So I'm going to move the x squared up top, y to the 4th to the bottom, and y to the 1st up top. So when you do that, you get x to the 10th over y to the 3rd, because I would do 4 minus 1, and the 4 is bigger, so that's where the y goes. Same way here, I would rewrite my exponents as positive. They have the same base, so I'm going to subtract. 7 minus 5 will give me 4 squared, which is 16. Okay, don't forget, if you have a power to a power, you need to distribute it to everything. So this is going to become 3 squared, x to the -8th, y to the 6th. It's all to the -1st, so I'm going to do the same thing again. I'm going to get 3 to the -2nd, x to the 8th, y to the -6th. And then I'm going to rewrite it with my positive exponents. So x to the 8th is positive, so it stays on top. I need to make the -2 positive, so it goes to the bottom. The -6 positive, so it goes to the bottom. So then you would simplify, you get x to the 8th, 9, y to the 6th, because 3 squared is 9. Okay, and the last example that I have, same thing, the negative to everything, so y to the 4th, y to the -4th, x to the -squared, over 10z x to the -2nd. Alright, so don't forget, I could add these are going to cancel. If I move these, the x's, they're going to cancel to make them both positive. One goes to the bottom, one goes to the top. So all I have left is that 10z on bottom, so don't forget I have to put 1 on top as a placeholder over 10z. Alright, and then I think the last 3 are probably the hardest. It says solve the equation. Don't forget, absolute value has 2 answers. Alright, so I need to add 13, 4z plus 3 equals 13. And then you write your 2 equations, so I say 4z plus 3 equals 13, or 4z plus 3 equals -13. And you would solve it, equals 10, 4z equals -16, divided by 4. So z is -4, or z is 5 over 2, because I simplified it. Okay, this one you've been doing since algebra, right? You're going to distribute. You're going to get 9t minus 18 equals -24 plus 8t. I'm going to subtract the t's to get them on the one side, add the 18 to get the numbers to one side. I get t equals -6. Don't forget, you can always plug it in to check it. Okay. B down here, same thing. You're going to distribute. You're going to get 6z plus 4 equals 6z plus 12 minus 16. I'm going to combine my like terms to get 6z minus 4 and 6z plus 4. When I subtract 6z, those cancel, so I get 4 equals -4. We got to ask yourself, does 4 equal -4? The answer is no, so that would be no solution. Right? If it said 4 equals 4, that would be infinitely many, but because it's negative, it's no solution. And lastly, they'll throw this at you. -2y plus 5 equals -8. Don't forget, if it's an absolute value problem and it equals a negative number, absolute value can never be negative, right? So the answer to this would be no solution as well. Okay, I just kind of throw that in there to make sure you understand it. An absolute value always has two answers on an equal sign. Same with an inequality. So inequalities you can always solve. It doesn't matter if it's negative or not. But if it's an equal sign and it equals a negative, you can't solve it. Okay. So I think this section is probably one of the tougher ones. I would definitely study this one, especially when it comes to absolute value stuff. Simplifying expressions. Okay, you've done this before, right? You're just looking for groups of 3. Okay, so if you do this, you get 4 and 16, 4 and 4. Don't forget it's a negative 64, so I need to write negative 4. How many groups of 3 can I make out of x to the 7th? Well, that would be 2, and I have 1 left over, don't forget that. And then y to the 5th, I can make 5 groups of 3 out of 15. And then don't forget you have an x left over, so that still stays inside the cubic root. Same with C, I'm looking for 3, or groups of 3. Okay, if you broke this down, 5 and 25, 5 and 5. It's going to be negative 5, x to the 4th, y to the 3rd. And this one has nothing left over, so that would be your answer. Now the thing that's tricky is if you have an even, okay, don't forget to put in absolute values. So I can make 3 groups of x's and 4 groups of y's, but because it was even, it has to go inside absolute value. And then that's 2 on the bottom, because I can make a group of 4 2's. So same way here, even, so it's got to be y squared z to the 5th inside absolute value all over 3. Okay, because if I broke this down, I can make 4 3's. Okay. Lastly, it says solve the inequality, write your answer interval notation, and then graph it. Right, this one's already set up for you. You just leave the y in the middle. That's what you're solving for. So if I add 8, I got to do it to both sides of the inequality. So I get negative 6, comma 9 as my answer. I use a bracket on 9 because it's close or less than or equal to. The next one, right, you solve it just like you normally would in the equation. So I get negative 2y greater than or equal to 7. Right, if you divide by a negative, you have to flip the inequality sign. So now I want less than or equal to, so if I graph it, I always like to graph it just to double check. It helps me make sure. So I would say negative infinity to negative 7 over 2 bracket. And don't forget, you're going to have to graph these. I have to graph the first one. So that's just a reminder of how to graph it. And then what I think is one of the harder ones is be an absolute value problem. Remember, it always has 2, so I write the first one. I decide whether it's an and or an or. I always do the weird thing on the right side of the inequality, right? So this would be an and, this would be an or. So this one's an and statement. So I get x less than or equal to 3 and x greater than or equal to negative 7. And if you graph it, right, after you graph them both individually, you should be able to see that the overlap's in the middle, and there should be an overlap with an and statement. So it makes sense. They're both brackets. Okay, if it was an or, you would have to use the union and shade in opposite directions. So that's how you solve everything for the first test. And then we have a couple extra problems that I forgot about because I had to throw in some more stuff just to kind of keep it differentiated. So it says solve the quadratic equation through the 3 methods on here. This one's factoring, so I need to add the 24 over, set it equal to 0. So 1 multiplies to 24 but adds to 10. Well, that's 6 and 4. And then you set them both equal to 0 and you'd solve, so it'd be negative 6 and negative 4. Okay, if it says solve using the square root method, right, you're going to square root both sides. Don't forget that's plus or minus, and then I would add my 4 over. So my answers would be 4 plus 6, which would be 10, or 4 minus 6, which would be negative 2. And then lastly is the quadratic formula. Okay, to remember it, I sing it, right? But you need to figure out your A, your B, and your C. So I would say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so same thing here, negative b, so 6 plus or minus the square root of negative 6 squared minus 4 times a times c all over 2a. Okay, so this is going to be 36 plus, that's going to be a really big number, 640 all over 4. So don't forget, you can always try the square root button, and this one it does work. So then I would get two answers. I would get 32 over 4 and negative 20 over 4, which you can simplify to 8 and negative 5. The quadratic formula does take a while, but it is the most efficient method as it worked for every quadratic equation. So make sure you study this over and over and over again. That way you only have to take the test once with me on a Google Meet. If you guys have any questions, please let me know.